Hello everyone, welcome back to another new video. We have a problem. This problem will be very important for our final examination. Okay, because such type of question is repeatedly asking in university examination. So you can see here in the question you have to determine the plastic moment capacity. So first read determine the plastic moment capacity. Okay, and section required for the frame is shown in the given frame over here. Okay, and the load shown in the working load given this 40 kilometer horizontal load. Okay, and this 80 kilometer is vertical load. So these are the working load. Okay, and you can see here we have to given load factor, that is the value of lambda is given is 1.75. Okay, and assume same plastic movement capacity for all the members. So it means plastic movement, that is the value of mp is given same for this. Here also mp, this is also for mp, and this is also for mp. So there is no changes in mp. Okay, now you can see here, first analyze the question. In this question you can see here we have two different load. Okay, first one is 40 kilometer, second one is 80 kilometer. Okay, and these two a and d are fixed support. Okay, so due to this 80 kilometer, this beam will deflect like this, and here will be beam mechanism. And due to this 40 kilometer, this beam will be sway like this, and due to this here will occur sway mechanism. And after these two load, okay, here will be third, in third step, combined mechanism, that is combination of beam and sway mechanism. So in this solution we're gonna show three different mechanism. So let's do one by one. First one is beam mechanism. Okay, so in beam mechanism you can see here, as I said, due to this 40 kilometer, this beam will deflect like this. And suppose this is delta 1, deflection is delta 1. Okay, and the value of amp is same, so we have to write here same. Okay, and this portion bc, this bc portion will be seen like this. Okay, and you can see here this load in acting at the center of this span bc. Okay, this is 3 meter from E to C. It means this total overall value is 6 meter, and this is 3. So it means this will be also our remaining B is 3. So this is 3 meter and 3 meter. It means this 80 kilometer is acting at a, exactly at the center of this BC span. Okay, so from here you can see this is this length will be our 3 meter, and this will be also 3 meter. So from here we can write here delta equal to 3 times theta. Delta equals to 3 times theta, as you can see here from right angle triangle, this right angle triangle. Okay, because in right angle triangle we know theta is nearly equal to tan theta, which is equal to p by b. So in the place of p we have to write here delta. So this will be delta by 3. So this delta can be written as 3 times theta. So delta equal to 3 times theta we have written. Okay, now we need to calculate internal work done and external work done. Okay, so first calculate the external work done because it will be easier. So external work done, we have to, for the external work done we have to just multiply load by the deflection. Okay, so 140 into delta. And now internal work done, we have to multiply this mp into theta 1, mp into this theta. Okay, and here will be same theta, this is also theta and this is also theta due to symmetric distance. This is 3 meter and 3 meter, and this point is load is acting at exactly center of BC span. So this will be mp into theta and mp into theta, mp into theta, this will. And for this point you can see here we have a two different load, theta 1, theta, this theta and theta. So mp into theta plus theta. So you can, this is written as mp into theta plus theta. So it means theta plus theta, 2 theta, 2 theta mp. So 2 theta mp. And after final we get 4 mp theta. Okay, so external work done we got 4 mp theta. Okay, this 4 MB theta in external work done, and this 140 into 3 theta internal work done, we have to get this. And after equalizing this, we get the value of MP, that is 105 kilonewton meter. Okay, in the place of delta we have taken this 3 theta, so we have written over here. Okay, so finally from beam mechanism we get the value of MP, that is 105 kilonewton meter. Now let's move to the second step, that is sway mechanism. Okay, we will solve this problem in three different mechanisms. So we have done first, now sway mechanism. So as I already said, due to this horizontal 60 kN load, this beam will deflect, sway like this. Okay, so from here you can see the external work done. No, there will be no change in the external work done. So first calculate the external work done. It will be easier for us. Okay, so for external work done, you can see here this 70 into this delta. Okay, so 70 into delta, and in the place of delta it can be written as this is you can see here we have the given distance, that is 4 meter. Okay, we have the given distance is 4 meter. So this theta can be written as delta by 4. So from here this delta can be written as 4 theta. Okay, so in the place of delta we can write 4 theta. Okay, now let's calculate external work done first. So external work done will be 70 into this delta. So 70 into delta, this is external work done. And for the internal work done, this will be MP into theta. MP into theta. This will be MP into theta. So MP into theta. And this will be MP into this theta. Okay. And for this will be MP into theta. MP into theta. So in overall we get 4 MP theta. Okay. And you can see here this is internal work done and this is external work done. So we have to equal these two value, internal work done equal to external work done. So finally we get this value, and in the place of delta we can write 4 theta. So in the place of delta we have written 4 theta. So from here this theta will be cancelled out, and the value of MB we got 70 kilonewton meter. Okay, and this 4 will also cancel out, so the MP will be 70 kilonewton. Okay, so from here we get the two different value, that is 70 kilonewton from sway mechanism and MP 105 kilonewton from beam mechanism. So 105 and 70 we got two different value. Now let's move for the next step, that is combined mechanism. So in combined mechanism we have a we have to show two different mechanism, and this is the due to the name combination we have to show both a effect in same figure. Okay, so due to this 104, this deflection seen over here, due to 70 kilonewton the sway can be seen here, that is delta 1. Okay, and you can also draw this portion like this. Okay, and this is now we need to calculate external work done and internal work done. So delta 1, this delta 1 can be written as this is 4 meter, 4 meter, so 4 theta, because in this case we have height is same, this is also 4 and this is also 4, so this all theta will be same, you can see here. And whenever the height of this frame will be different, suppose we have such type of frame, this will be 4 meter and this will be 6 meter. In previous video we have done such type of problem, so you can go and watch from the playlist. Okay, in such type of problem this angle will be different, this will be theta 1 and this will be theta 2 and theta 2. So never forget this, just remember, keep in mind. Okay, but for now our question is simple, because we have given both 4 meter and 4 meter. So we can take all theta same. Okay, we don't need to take different theta. So from here you can see this in the place of delta 1 we can write 4 theta. Okay, and here now let's calculate internal work done, external work done. So external work done 70 into this delta 1. So external work done will be 70 into delta 1. Okay, and due to this 140 kilometer, this 140 into delta 2, deflection will be delta 2. So we have to multiply the load by the respective deflection. So due to 70 into delta 1, this one, due to 140 into delta 2, 140 into delta 2. Okay, so in the place of delta 1, and we can write 4 theta. So in the place of delta we have written 4 theta. Okay, and in the place of delta 2 you can see here this is our 3 meter, this is 3 and 3 meter. So this 3, so this delta 2 can be written as 3 theta. So in the place of delta 2 we have to write 3 theta. So from here we get 700 theta external work done. Okay, so we get external work done 700 theta. Now we need to calculate internal work done. So for the internal work done, we have to take the value of MP and we have to multiply the respective angle. So this will be MP into theta, MP into theta. Okay, here this will be MP theta. So this portion, and due to now the remaining we have two different points. Okay, okay, so now remaining two different middle span, that is for point C, this will be MP into theta plus theta because we have two different theta. So MP into theta plus theta, and for here we can see here MP we have also two different theta. So MP into theta plus theta. So in overall we can see here we get the total value of, in the place of theta we can write both, all are the same, all are the theta, so we don't need to change. So finally we get all, after adding this all we get 6 MP theta. This is internal, and external 700 theta. So equating these two value, okay, equating these two value we get the value of MP, that is 116.67 kilonewton meter. Okay, so this is our required answer. Okay, so from here you can see we get three different value of MP. 116, okay, from this combined mechanism, okay, and 60, this one 70 kilonewton, this one 105, 70, 105 and 116. Okay, so in overall we get a three value, 17, 105 and this one 116.67. From combined mechanism the maximum value occurs 116.67, this one, and from beam we get 70, and from sway we got 105. So in this comparison of these three value you can see here the maximum value is 116.67 kilonewton. So from here we have to write and we have to take the maximum value for the plastic moment. So from here the maximum value occurs in combined mechanism, that is 116.67 kilonewton. So our plastic moment will be in combined mechanism, that is 116.67 kilonewton meter. Hence it can be written as, thus the combined mechanism is a real mechanism. Okay, so our combined mechanism will be real mechanism. Now we have taken the highest value. Okay, I have also written over here, that is 116.67 kilonewton. Okay, so I hope you got all the concept regarding this video. Thanks for watching, and such type of question is repeatedly asking in our final examination. So thanks for watching. Thank you very much.